Hello. Okay. Hi guys. Today we're going to emulate an attacker who will be doing some pretty neat stuff on a target, which will be Windows 10. This is a Windows 10 system that is patched, so it's expected to flag malicious um, executables. So let's see if we can maybe use a drive-by download attack vector to get our initial access, then see how we could possibly escalate privilege using one or two techniques, which I think are pretty neat and cool. We'll be using Metasploits. I think this will be the last video for our network-based attack. Then we'll move into web application attack from next week, from this week, probably Friday. We'll be looking at the web goods as our web application, vulnerable web application. Then we'll be using tools like Zap proxy, Burp proxy to probably play around. Yeah, that's I would I think it would be fun if you can set up your own environment for web goods, and so you can maybe follow up with the class. But cool. All right, so this is the targets. We will skip quite a number of the phases like scanning, enumeration, footprinting. We will still do some enumeration, but the initial phase, because we'll be assuming that we already have an initial access on this Windows box. So to do that, let's see if we can quickly grab, since it's here with me, I'm just going to get the IP address, skip some of the processes. So it's .4, great. Then on the attacker Kali VM, I'm going to run the sets toolkits. Then I'll be using two different sessions for the set toolkit because I want to use a different method, since I'd mentioned drive-by download, so I was just upgrading. I think it failed. I'm not sure why that happened, but let me try again. Okay, it's done except for one not upgradable. That's fine. So we're going to be using the social engineering, but this time around we'll be using the infectious media generator. Let's see what that looks like. So 3, then we'll pick the attack vector you wish to use. We'll be using the standard Metasploit executable, so we'll use option 2. Then we will, the options that are given, we can either get a reverse shell, reverse TCP, but I think I'll use the MetaPreader. Use reverse TCP MetaPreader. I think that's option 2. You could use the staged or the stageless. I think it's some of the things which we'll talk about probably later on towards the closing part of the course. We'll do some theory. You get to understand how the MetaPreader shell works when it's staged and when it's stageless, and how does that affect your payload importing into your remote host. So we'll be using reverse TCP. That will be option 2. Okay. Then the L host, which is our listening host. I'll quickly check the IP ADDR. I think we're at 15. Okay. So we're 10.0.2.15. Then they enter the port for the, I will use 443 rare, but let's see how that's going to behave. Assuming there's a firewall, if it's possible to bypass the firewall. So we're generating the payload. Okay, create a listener. We've generated the payload. The payload is in a directory called /root.set is a hidden directory. So let's see if we can access that directory and list its content. So we'll see the root.sets. So we can see we have a payload.exe. Then in the auto run folder also, we should have the auto run part of it, the program.exe. So we could use either this or the payload. So I'm just going to, I'm going to clear this screen. Okay, I'm just going to go back. Okay, great. So what I'm going to do is I could use, in one of the videos that was sent to you, we saw how you could use the social engineering aspect of the set toolkits to send that to our targets using the mass mailer. So we could use the mass mailer and email attract for single. That should be one. Then we could send to that target email address that is logged in here. I think it's where is it? Oh, it's not this one. This one is my personal. Oh, I think it's not on this box. Okay, great, but I'm not going to use that attack vector. I think that was on the server box. So you could use this attack vector also to send this payload to the target. Oh, excuse me, to the target. The target email address. They click on it, then it does magic. Great, but we're not doing that. We just send a malicious link. But today we'll stand up a Python server. So we'll stand up. Oh no, sorry. So what we're going to do today, we will do ngrok. I think it's in opt directory. Okay, so we're going to use the Python server. In this directory where we have our payload, we'll set up the Python. On ports, let's say we use port 7000. Okay, then we'll set up ngrok to expose this local server to the targets. So we'll use ngrok. I think it's HTTP on port 7000. Let's see if we can get that exposed. If you can get that exposed, great. So this is the HTTPS link. So which means if our victim visits this link, they should be able to download our payload. So let's say we copy this link and look for a way to send this to our victim. So I'm going to copy this link. It looks clean. It's not a malicious link. So I'll just put it, since I have this email signed in that host, I'll just put it in this email and probably save it as a draft. So I'll save it as draft so the victim can go and download it. I think it's in draft. Great. So I'll switch to the Windows host. I'm skipping a lot of steps that could possibly be done, and I'll look for that link in my drafts. So imagine this was sent to the victim. It's a HTTPS link. Like I told you earlier on, I could use a link modifier to shorten this link or make it look like a legit link, or I could pay for ngrok and they will give me the ability to do that. If I have a paid account with ngrok, I can actually modify that link to look pretty legitimate, like a very real link, and the user clicks on it and it takes them to where I want them to go. Or I could clone a very known website, a web page, and host it on the server, then point it to this link. So if I'm hosting it on my Python server and I'm using the ngrok to expose it, if they click on this link, it will take them to that malicious server that web page that I've cloned and it's been hosted by my Python server. So let's assume the user copies this link. If I had sent it via an email drive-by download, they could just click on it in their email and it takes them to the, so let's say that's what we're assuming has been done. So the user clicks on the link, it takes them to that my malicious website. I'm hosting this. You see the browser did not put the slash because this is a HTTPS and it's got a secure, you see the padlock is being shown, they're telling you it's a secure link, but I'm actually hosting this locally, this server locally. It's just a redirector that is doing the job for me. You see why you shouldn't always rely on the padlock as a way of saying that you are visiting a safe website. No, it's not always the case. If you have a padlock, it doesn't mean you're safe. As in this case, there's a padlock. The browser did not flag anything malicious because ngrok is exposing my local server for me. Cool stuff. So I could social engineer the victim, but before that, let me set up the listener. So I'll click a yes here. I want to listen. So I'll launch Metasploit and I will listen for incoming connection or reverse connection. So we have that handler set up and listening. Remember, this is on port 443. So if there's a possible firewall, it could bypass the firewall because usually on firewalls, traffic from 443, 80, 53 are usually allowed. So this could be this is wrapped in HTTPS and it's going directly to the 443 port, which is allowed on the firewall. So I can bypass the firewall using that method as well. So if I'm going to social engineer the victim and they click on my payload.exe, let's see. Obviously, Windows Defender flags this because it's just a vanilla payload, but we could keep it. Let's social engineer them and get them open the file. That's just all we want. Now, one way I could get this thing to bypass Defender, if I have a certificate, I could sign this executable with my, if I have a valid certificate, I could sign this executable with my certificate, so which means it should not be flagged as it has been flagged, because if you look at it, it's telling me the publisher could not be verified, which means that application is not been signed, and Windows definitely will only want to run signed, digitally signed or verified app. If you look below here, you will see this file does not have a valid digital signature. So which means if I have signed it with my digital signature, I could possibly bypass this security control in place that is preventing me from doing this. But that's something which probably we could do in the future. Grab a certificate. For now, I don't have a certificate. I think the last time I had one was last year. I was on a job and I had to subscribe for, but I didn't renew that certificate last year. So I don't have anything to use to sign this. Anyway, so moving on, I will just run this and yeah, it's staging. So we grab a shell. So you look at the MetaPredator screen. So we have a MetaPredator session 1 open. So let's go look at that. Let's minimize the windows. It seems like nothing happened here. It just clicked and nothing happened. But if I had if I had gone into maybe event viewer, I could possibly have seen, let's just see if we can go into Windows event viewer, run as administrator. I will have to, let's see if we can look for a log, or we could even check the Windows log directory. There's a log directory in Windows which we could check to find out what has happened then. There's an application I was trying to install that can actually do that for us easily. I think I didn't get to finish the installation. Let me see if it's there. Oh no, it's not here, so it's in the other user. I think it's in the admin user. Let me see. I think this is not an admin. Oh yeah, this person is not an admin. It's just a user. Okay, so I think that application is in the admin because I had set up local group policy to prevent non-admin from actually executing certain kinds of installing application and other stuff like that. Okay, great. So that's fine, which means we're not an admin. Whatever shell we got here, it will be a normal user shell. So let's check the sessions. I see there's session 1. So let's start up that interactive session. So we can check get UID. You see, we're just in this domain, MS Edge Win 10 domain, and then we're the user IE user. So can we load PowerShell? Let's see if I can use some get. Okay, and let's see. We have the execute. So I have to use the PowerShell execute. So there's an error saying it's not recognized, so that's not a CMDLET. So I have to load a particular CMDLET that can allow me to do that, but it's fine. If you look here in MetaPredator, we can see there are quite a bunch of stuff there. Now this is what happens. We have initial access. Let me say I run a PS. I could see that most of the processes here are run based on the user space, which means I don't have any process running as an admin, which means that user is not an admin. It's just a normal user. Look at all the processes running. These ones that are hidden are usually admin, NT authority according to Windows, but see, they are not being displayed there, so which means I don't have any access to these processes. I don't have a read, I don't have a write access to these processes, but the ones that shows my user instance, I have some access on these processes. So fair enough. If I try to, maybe let's go back again to the MetaPredator and do a help. If I try to maybe there's a command here in the MetaPredator shell that I can use to I can try the hash dump, or I could try the get system to see if I can elevate my privilege. Let's try the get system, see if it's going to work. So I'm going to do get. You see, it told me access denied, which means I barely have an admin access. I just have a normal user access. I can do nothing on this box. Sad as it may sound, but that's the reality. Okay, so what I'm going to do, since I have my initial access, I'm going to kill my Python server, stop hosting my server, trying to clear my tracks, so they don't get to see what I'm doing anymore. So I'm trying to clear my tracks. So let me try to hash dump. Is it possible? I cannot dump the hash as well, so which means I don't have access to do that. Now there are several techniques I could try. I could look for ways. I could drop to a shell and probably look at where I am. I'm in the download folder. I could see if I could go back maybe to see the users. Oh, sorry. Then I could see if I could switch to the admin. I see the admin is usually, I think the admin is the, let me see if I can switch to another user. Access denied. So see, I don't have write access on this directory. Maybe I've got read access so I can view it, but I don't have write access. I don't think I even have read access. Let me try maybe public. So that's public. I can actually have read and write access. Fair enough. I could list the content of that folder as well. So that's public. But if I try to do for another user, like this user that I tried, see, I got access denied. So I have no read write access on that. So what I could possibly do is I could go back to my MetaPredator shell. Then there is what we call, there is actually a module, a post module in Metasploit that I could background this session, and let's search for exploits suggester. There's a post module in Metasploit that I can use to run on the Windows box. It will tell me other vulnerable path that I could use to maybe escalate my privilege on this Windows box to admin, so I could dump the hashes and maybe elevate my privilege. So if you look here, there's the module called the post multi-recon local exploit suggester. So I'm going to copy this because I'm going to use this module to enumerate. So I'll go back to my sessions. So back in my session, I'm going to run the post module. Let me see, on the Windows box. So it's collecting local exploit for x86 architecture Windows. Let me see if I could probably find a path of least resistance, more like low-hanging fruit, without having to break my head to go through doing detailed enumeration, trying to find a possible exploit I could upload and elevate my privilege with that exploits. I'm just using the metaplayer shell that I have, or the metaplayer session that I have. That's one usefulness about Metasploit actually. It's quite flexible. It's got some very good modules that can help you automate stuff. This is actually automation happening. I'm not breaking my head trying to go find all these exploits from the box. It's just running this scripts and finding all these exploits. You can see there are a bunch of them. So it's telling me that there is a bypass UAC event viewer, and this box, that Windows box, is vulnerable to that. There is a bypass UAC fault helper, is vulnerable. There are several modules. There's a vulnerability here, the print daemon. This one is pretty much recent. Then this is also pretty much recent. There's IKE as well, service, and it's vulnerable. So I'm just going to pick one of them. Let's say I use event viewer. I want to bypass the user access control that was restricting me from carrying out administrative task. So I'm going to grab this exploit module. I'm going to work with this one, which is the first one. Let's see if it doesn't work, we try another one. So I'll background this session, then I'm going to use that module. So I'm going to set the payload is set by default to metapredator reverse TCP. Is fine, I'm okay with that. Then I'm going to set the session. Since I have got the session 1, that's what it's going to use. Then I'm going to run this module. Let me see what happens. So it's attempting to bypass, configuring payload stage, or executing the payload event viewer.exe. So what it's doing is it takes this malicious event viewer and try to replace it with a legitimate one there, and see how that will be used to bypass. So if you look at what happened, exploit completed but no session was created. So the exploit was done, but I didn't get a session, so this didn't work. Anyways, if I check .i, it seems like I don't have another session. I'm going to try another one. Let me try the second one, or let me try the third one. Let me see. So the first one executed, but no shell was created, no session was created. Let me try this one. So I'm going to use this one. Set session 1, then run. Let's see if this will work. It's still a UAC bypasser executing the payload. This is modifying registry keys. So it's looking for the verb runners. Runners is something you usually find, but no session was created. Again, I didn't get a session. So if what runners is basically, oh no, I'm gonna cancel this. It's asking me for product key. Oh my god, I shouldn't have updated this thing. I think I ran an update. Now it's asking me for product key. I'm going to revert it anyways. So what runners is something that is something in Windows that gives you the opportunity to run command as a different user. So I could run as maybe that user. Let me see. I could use the runners to run something as this user, any user that I want to use. So let's say I want to run PowerShell I could run PowerShell as a different user, or I could run PowerShell as another user that is not my own user. So if you look at here, you see run as allow you to do that. So but this didn't work. Let's try the third one. Oh, the second one. Let's try the second one and see if that's going to work. Oh, sorry. No, I'm going to cancel that. So I'm going to use, okay, set session 1 and run it. Let's see this one. For the app.exe, cleaning up registry. Are we grabbing a shell or not? Is it giving us a shell or not? I'm waiting for that to load. Like I told you, I just updated the Windows box, so it's patched. So most of these exploits, it's not allowing them execute, although it's saying that the system is vulnerable to those exploits, but it's not even allowing it because it's been patched. So let's wait for this one to see if this one will do something. There's a slight delay. I see the stager is sending this quite a large one. Great, this one worked excellently. That's quite a large stager. It's almost to convert this to kilobytes. That's about 17 or 175. Okay, so we can see that we have a different session. So I'm going to background this. Let's list our sessions. Now look at this. We've got two different sessions. This was the initial access and this is the second session. So let's interact with the second session and see if that's an admin session. So we use session 2. Oh, sorry. Okay, great. So let's get UID. Sysinfo. Let's see. It's Windows 10, the build, work group, logged in user 2. So we have 2 users logged on. Okay, great. So now let's try, since we are in this new session, let's do the PS again and see. So if you look at this PS now compared to the first one, I can see these processes that are running as administrator with this new shell, which means this is an admin shell. I can see SVC. It's telling me it's NT authority local service, NT authority system. That's the highest hierarchy authority on a Windows box. That's an admin privilege. Then if you go pretty up, you will see quite a bunch of other processes running as admin. All these processes we did not see in our first PS, which we did on the other shell. So this tells me that this shell is actually an admin shell. Great. I can see there's a ruby.exe. This smells like Metasploit stuff. Okay, and it's running as NT authority. Great. So that's just what I want to show you first. So now at this point, we will go back again and try to see if we could dump our hashes. So we will first do let's try the get system. Let's see. Now you see we've got the system. We've impersonated a named pipe and we've got a system admin, right? Then if you can try the hash dump, privilege password operation failed, parameter is incorrect. Oh, privilege password get some hashes, operation failed, parameter is incorrect. Let's try get system again. If this doesn't work, then we could type some help. Let's do some Mimikat. So we'll load Kiwi and see if we can use Kiwi to dump that hash. Great. So there are quite a bunch of other things you could do. You could get a desktop if you want a desktop. For those who are desktop freak, you could get desktop. It will give you a snapshot of the current desktop. You could upload a keylogger, which monitors every keystroke that the user is typing. Key scan, key stop, mouse grab, screen share, screenshots, set desktop. You could change the metapreader to desktop. In desktop, list all the possible windows on a desktop. There are quite a bunch of other things you could do get priv. Let's try the get priv and see. Great. So all these are possible privileges we could impersonate. There are quite a bunch of them. Let's see, there's a module that can allow you actually impersonate. Let's see if it's loaded here. If it's not, we can load it. Migrate. Okay, let me try something. Maybe the process under which I'm running cannot allow me dump those hashes. So what I'm going to do is I'm going to change my process. This is local security authority 604 and it's running as NT authority. So let me migrate to 604. See if I can migrate. If I migrate, then I should dump the hashes. Isn't that process great? Now I can hash dump and there shouldn't be a oh great, it was only able to dump the administrator's hash. Okay, we're not there yet, we still have to take a step further. So at this point we can see the administrator's hash. We could grab this hash, maybe authenticate with the hash or try to crack this hash if we wish, but let's still play around. I want to dump all the complete hash. So let's see what again is in MetaPredator shell. We've tried the God system, we've tried the privs, we've tried, we've changed, migrated to a different process. Okay, to clean up our asses, we could use the bgkill to kill all the MetaPredator scripts or kill all the listening scripts, but we're not there yet. We're trying to see how we can dump all the hashes in that box. So I think there's no other module here. So what we're going to do is we're going to load Kiwi and see if Kiwi can do the magic. Let's load Kiwi. Kiwi is actually Mimikat's elder brother. Okay, so I'm going to dump all the credentials using the creds all. If that does the magic. Oh my god, error running command creds ID for nil class. So there's a problem. Let me try the LSA SAM dump SAM. Okay, so we can actually dump the SAM. Great. So this is the SAM. So we can see the domain, we can see the system key. This is a very unique key for that particular system. We can see the local seed, if you know what the seed is, system identifier. We can see the SAM key. Interesting. Wow. So with this we can actually view all the SAM files. Then we can see the NTLM hash for administrator. This is the NTLM hash. I think this is NTLM version 2. We can see these other accounts, WDA whatever. We can see the IE user. Great. And this is the hash. And we can still do other fun stuff. Let's see other Mimikatz Kiwi's module. Let's see if we can dump the secrets. LSA dump secrets. Okay, so there's an encryption happening here, but I can see something interesting. Let me show you something interesting. If you've got an eye for it. Again, we can see the domain, the system key, but follow me as we go down. The LSA key is given. This we can use to actually crack the secret. But look at something. I saw a cached default password. This is unique, and this is, I think this is actually the password. It's telling me it's password 1. Let's go try it. Let's go log in as the admin. The admin of this box is IE user. So let's maybe lock the screen and let's log in. Let's be sure that's the password. So it's PASSW0RD. Boom, there you go. That's the power of Mimikatz. So it gave us the password, clear text password. It gave me the DP API system key as well. which is also something unique if we want to do some cable roasting. Maybe we'll do some cable roasting later on, but all these other things are encrypted. Again, there are quite a bunch of other things which we can do with Mimikatz. Wi-Fi lists. We could list all the properties of the Wi-Fi card, Wi-Fi list shared. If there are secrets or passwords of Wi-Fi that system has connected to, we can dump all of them here. You see all the Wi-Fi password that the system has ever connected to. That way you can grab the password. We could even change the password. Since we have the hash and we have the password, we can change the password for that system. That would be fun stuff to do. Okay, then we could grab a CMD, or we could start doing some cable roasting stuff, interesting stuff. But I think basically that is it for today. We've been able to see how we went from a normal user to an elevated user, and at this point we can start dumping stuff, doing some other stuff. We could upload, using the upload command, upload some very funny Windows binaries. If you go check out in Kali Linux, there are binaries that you could use. Let me see if I can go to that folder. Let me see, I still have this payload here. I'm going to clear this payload. Okay, so let me do that here. Let's see the user share Windows binaries. There are quite a bunch of fun stuff. I could grab a malicious, I could import, upload WinP. I think I'd shown you a video where I was doing WinP, but let's just look at it. Let's say we upload. Where are we first? Let's see. In which directory are we here? It's taking a while to do that. Don't tell me the session has crashed. Okay, so let's pwd, let's see, system32. Let me go back to the C. Let me stay in Windows. Okay, let me go back. Okay, I'm going to upload Mimikatz into this C directory. So I'm going to upload is user share Windows binaries. Then there's a winp.exe. I could upload nc netcats and set up a stager, a listener, then execute netcat to connect back to grab another shell just for persistency's sake. I could upload a keylogger if I want. I could upload the wget, install it, or vnc if I want a desktop view, or even remote admin if I want another shell that is hidden. There are quite a bunch of other scripts in the enum plus which you could play around with or try your hand with, but I'm just going to import winp. Let me see what architecture first is here. So do system info. Sys info is x64, so I'm going to grab winp x64, upload user share Windows binaries winps x64.exe. I'm uploading that. Boom, it's done. So let's list the directory and let's see if we can execute that program. Let's see if we can drop to a shell just to make life easy for ourselves. dir. Then there goes our winp in the Windows box. So let's execute it. Winp x64.exe. Boom. Some fun stuff. It's going to show us a bunch of other stuff, like a bunch of other stuff. Just wait for it. It's giving us useful details: the host name, the product name, the release dates, the architecture, the keyboard language. Very, very interesting, fun stuff. All the hot fixes. Okay, so everything you're seeing with the red, it's actually bad configuration, or revealed files or stuff that are not good. So let's go all the way to the top and let's walk through what WinP had done. It's done its magic. Oh no, it's so much that I exceeded the buffer. I can't go up anymore. That's too bad, guys. Okay. Okay, but you can see some fun stuff. Master keys being revealed. We could go all the way down, giving me some areas I could grab file to exploit some of these services running on the box. Let's just look for some red. You could dump credentials remotely from here. Grab a link to where you find how to do that. Going all the way down, look for some red. Okay, unattended files, useful stuff. You will find passwords in here. Group administrator, name, IE description, IE user. Work with me, please. Okay, group administrator. IE user is an administrator. Hide wireless setup. It's true. Synchronous commands, some commands. Let's go down the policy execution, remote force. Going down, it's giving me some AD configuration, some registry key set that are sets that I could exploit. Go down, you could, if you look clearly, you could even find a password. If there is a clear text password, you find it in here, unattended files. But it's a bunch of stuff. I'm not going to spend my time doing that. That's for you to play around with. Then Credential Settings Xml. So roaming credentials. So there's there's something called roaming credential. Looks like an interesting. There's something called password.txt. Looks like their password stored in here. That seems more like a very hidden directory, but you can see there's a Microsoft Edge users. The Edge user passwords are stored in password.txt. You could go dump all those passwords if you want to. We'll just navigate to this directory and view the password.txt file. See all the passwords in there. We could, that's for you to try. Net user, I could view the net users, all the users in the box. I already have administrator rights anyways. Thanks for telling me that. Okay, so I could see bunch of flags, bad file permission, bad file permissions. I could exploit. It's more like what you call access file permission in Linux. What you see, you set in access control on files, either read, write, execute, or sticky bits. And the same thing has been applied here on Windows, but we've seen that there are bad file permissions. I have read, write, execute on these folders that I shouldn't, and that's quite bad, really bad. Okay, there are a bunch of them. I don't want to tear my eyes down because I'm not being paid to do that job anyways. Okay, anyway, so I just want to show you that, and it's still going on. I could still see some useful stuff, but I think I'm going to call it quit here today. It's the video has actually extended. I hope I can upload this. Thanks, guys. The caveats. If you go backwards, how it began, it was a drive-by download. So the attacker was hosting a payload on a website, just like what we're seeing happening every day around us. You visit the website, you click on the link that looks very legit on the website, you got infected. From that infection, the person gets access to your system. From there, he enumerates your system to find out weaknesses. Then from those weaknesses, he was able to grab admin level right on your system. Then from there, he starts exfiltrating data, either stealing some of your data or importing ransomware that encrypts your entire disk and actually to pay some ransom. Fun stuff to do. Okay, maybe on a good day we could set up a system and have a demo about ransomware, so you see how it starts the encryption, then how fast it takes to encrypt the entire disk. Maybe we'll do a demo for that. But to keep yourself secure of stuff like this, one, do not visit links that you're not sure of. Be sure you know what the link is. If possible, copy the link, put it in the notepad and view what the link is. If you're not sure about it, if it's unsolicited, do not click it. Two, do not download most free resources you find. I could take, for instance, you want to download free Microsoft Office. I could reverse engineer the office.exe file, then I will put in it a payload that will call back. Maybe I use MSF Venom to wrap. Maybe I could show you that one final lesson before we call it quits. I think I've got those payloads in here. If you look at this folder here, you'll see the payload encoder, payload generator. I could show you how you could take a very legit application like TeamViewer and use Metasploit to wrap a payload around it. So I put it up on the website and you download it free, no license. You download it, you install it. The moment you install it, it calls back to me. I have access to your PC. Now that's something that we see prevalent because most people usually go download free stuffs. That's why we also advise not download free stuff, pay for stuff. If you can't pay for stuff, try not to download free stuff. Anyways, this is it for today. Stay safe on the internet and peace out.